Welcome to the debate. For over a century, managing an elite football team was, a lot like steering a massive ship by only looking at its wake.
That is a very apt way to put it, actually.
Right? You sit in the locker room after a painful loss, you pull up the video the next day, and you just painstakingly dissect the tactical mistakes. But the damage is already done.
The points are dropped, yeah. You just learn for next week.
Exactly. It was a retroactive autopsy. But step onto the touchline today, and that paradigm is completely shattered. We are no longer steering by the wake. We are looking at a real-time, zero-latency radar system.
And for anyone studying sports management, this is the defining shift of our era. The integration of real-time artificial intelligence right into touchline management.
Yeah. And the core question we are tackling today is whether this integration, this real-time AI and sensor fusion, provides an indisputable scientific advantage for tactical and physiological decision-making.
And we are really focusing on the pros and cons of this tech for those future decision makers, right?
Precisely. I will argue that the pros are undeniable. It eliminates guesswork, and it transforms managers from reactive observers into proactive tacticians, providing a flawless framework for in-game decision-making.
Well, I approach this from a fundamentally different angle. There is no denying that the data capture itself is an impressive technological marvel, but we really have to examine the cons of adopting this framework as gospel.
How so?
Because treating a fluid, deeply human game as a purely mathematical equation risks creating immense computational rigidity. I will argue that attempting to overlay an instant mathematical order onto a sport that is fundamentally chaotic, it can lead future managers to over-rely on algorithmic thresholds.
Meaning they might misinterpret the actual reality on the pitch?
Precisely. They risk missing the nuanced, deeply unquantifiable realities of the game.
I see where you're coming from, but to understand why this shift is the absolute greatest advancement in sports management history, we first have to look at the mechanics of the technology. Specifically, how the temporal gap has collapsed to zero.
The time between an event happening and a manager understanding its significance?
Right, exactly. We are talking about edge computing. Rather than beaming heavy data to a cloud server hundreds of miles away and waiting for an answer, the servers are physically built right into the stadium architecture. The processing happens practically on the touchline.
Entirely eliminating lag.
Yes, and the data it processes is just staggering. We have sensor fusion at play. The match ball itself now houses an inertial measurement unit, or IMU. Think of it as a highly advanced version of the chip in your smartphone that tells the screen which way is up.
Oh, right, the accelerometers.
Exactly, but placed inside the bladder of the ball to measure exact acceleration, gravity, and spin rates at 500 hertz. That is 500 times a second.
And that is paired with the optical tracking. You have an array of synchronized cameras positioned around the stadium roof, mapping the skeletal structures of all 22 players.
It's incredible.
They are capturing 29 individual data points per player. Shoulders, knees, toes, hips, and they do that 50 times a second.
Which means when you merge those massive, asynchronous data streams, the AI essentially creates a millisecond perfect digital twin of the live match.
For a student of sports management, the pro...
In the farthest reaches of space, one scientist refused to stop searching. Every discovery uncovers The Scientist Explorers. Available now, just $4.99 on Amazon Kindle Unlimited. Start the adventure today.
For a student of sports management, the pro here is incredibly clear.
The professional advantage, you mean?
Right.
Touchline decision-making is no longer driven by a gut feeling. It is about executing data-backed interventions with scientific precision before your opponent can even materialize a goal-scoring opportunity. You are quite literally seeing the matrix of the game as it happens.
Well, rendering a digital twin of a live match requires astonishing computational power, sure, and I certainly recognize the sheer engineering triumph of edge computing.
It is a triumph.
It is, but we have to question the philosophical assumption driving its use in sports management. That assumption is the idea that more granular data automatically equals better managerial decision-making.
I think it objectively does.
I disagree. Football is, by its very nature, a chaotic, continuous, and fluid sport. It is not segmented like baseball or American football. By viewing players merely as kinematic outputs and 3D topological maps, we risk losing the human intuition required to manage the live match.
But the data provides clarity amidst that chaos.
Does it, though? Algorithms cannot capture human intent. They cannot measure psychological deception, and they certainly cannot quantify the emotional weight of a World Cup knockout match. If sports management programs only train future decision makers to manage a digital twin, they will eventually forget how to manage the actual human beings running on the grass.
I hear you're concerned about losing the human element. I really do. But let me demonstrate how this actually operates in practice, particularly regarding tactical decision-making and what the models call structural anomalies.
Okay, let's hear it.
So, the Edge AI servers are processing millions of spatiotemporal data points live, and they feed actionable insights directly to the dugout tablets. One of the primary tools here is expected threat, or XT, calculated on the fly.
Right, the probability metrics.
Exactly. Expected threat evaluates the pitch as a living probability map. It calculates the likelihood of a possession resulting in a goal based on the exact spatial arrangement of the players at any given millisecond. It uses momentum vectors, like which way a player is running and how fast, to determine who will arrive at a loose ball first.
So it assigns a mathematical value to every patch of grass based on who currently controls it.
Yes. Now, let's look at a specific tactical scenario. Say an opposing team suddenly shifts their pressing trigger, or their fullback begins leaving a statistically significant pocket of space behind them.
Which happens constantly in a live game.
It does. But to the naked eye, from the touchline, amidst all the noise and the blinding speed of the game, a human manager might not notice that subtle 5-yard drift for 10 or 15 minutes. But the machine learning model flags this structural anomaly instantly. It sends an alert directly to the tablet.
So it's basically doing the manager's observation for them?
Think of it like chess. In chess, if your opponent leaves a bishop undefended, a digital chess engine glows red to highlight the vulnerability. In football, if a fullback's hips are turned the wrong way and they drift out of position, the tablet glows red. It turns subjective mistakes into objective vulnerabilities.
Okay, but
Just to finish the thought for a sports management student, learning to use this is revolutionary. You don't have to wait for the 15-minute halftime window to draw on a whiteboard and adjust your shape. You execute heuristic, data-backed shape adjustments mid-phase. You exploit that fullback's positioning the very next time your team wins the ball.
that entire argument assumes the vulnerability is actually a mistake. Which brings us to the fundamental difference between a mathematical anomaly and a tactical reality.
A vulnerability is a vulnerability.
No, it isn't. Your analogy is flawed. Chess is a game of perfect information. Both players can see all the pieces and the rules of movement are absolute. Football is a game of deception. Let's examine your fullback example closely.
Sure.
The algorithm flags that a fullback is leaving a, quote, statistically significant pocket of space. The tablet lights up red. The AI dictates that the manager should exploit this space. But how can an algorithm differentiate between a genuine tactical error and deliberate human deception?
It evaluates the geometry of the...
Wait, hear me out. What if the opposing manager has explicitly instructed that fullback to show a little bit of space, precisely to bait your winger into making a run into a channel where their defensive midfielder is waiting to trap them and launch a counterattack?
That's a highly specific hypothetical.
But it's how the game is played. The AI sees a structural anomaly and mathematically assumes it is a flaw. A seasoned manager with contextual human intuition might recognize the bait.
But your argument assumes the AI only evaluates the isolated player in a vacuum. It doesn't. The machine learning models are trained on tens of thousands of hours of historical match data, and they evaluate the global structure of the pitch.
Even so, deception is subjective.
If a specific spatial opening is historically a trap, meaning it usually results in a turnover rather than a successful penetration because of the positioning of that defensive midfielder, the expected threat calculation accounts for that defensive cover. The probability metric adjusts accordingly, and the tablet wouldn't advise playing into that space.
But a fake run or a tactical trap relies on mirroring the exact kinematics of a real vulnerability until the very last millisecond. If a player sells a dummy run, their momentum vector, their hip rotation, their acceleration, it all perfectly mimics genuine intent.
The models can differentiate.
They can't, because the physical output of deception is identical to the physical output of a mistake. If a manager reacts instantly to every single algorithmic alert that flashes on their tablet, they risk falling into a state of constant reactive tinkering.
I think you are underestimating the...
Football relies on organic rhythm, on players developing a feel for the game and for the opponent's cadence. If a manager is micromanaging shape adjustments mid-phase every time a spatial metric fluctuates, they actively destroy their own team's rhythm. They fall prey to the illusion that computational speed equals tactical wisdom.
Well, that tension between reading human intent versus algorithmic data doesn't just apply to where players stand on the pitch. It applies directly to their physical bodies as well. Let's transition to the physiological pros of this technology.
The biometric tracking.
Yes, because I believe the case for real-time AI becomes truly undeniable when we discuss player welfare and physiological management. We are talking about continuous kinematic monitoring. Computer vision algorithms are not just watching where a player moves, they are continuously monitoring the biomechanics of how they move.
They track high-intensity sprint metrics, right?
Exactly. They map deceleration efficiency. They detect micro-alterations in running gait.
By generating real-time fatigue indexes.
Yes, and the mechanism for how they do this is vital for sports management students to understand. When a center back decelerates to change direction, the camera array measures the exact loading force on their left knee. The predictive neural network then compares that live loading force against their historical baseline.
Data gathered from thousands of previous matches and training sessions.
Precisely. Now imagine the reality of touchline management. A manager looks at their star center back. The player insists they are fine. To the human eye, they look completely fine. But the algorithm detects that this center back's lateral agility has dropped below a critical threshold.
And their deceleration mechanics are asymmetrical, presumably.
Right. The predictive network signals that this specific biomechanical drop correlates with a massive 90% spike in the probability of an imminent soft tissue injury, like a hamstring tear. The AI prompts the dugout to make a precise, preemptive substitution.
And you see no downside to this?
I see it as the holy grail of sports management. It removes the profound danger of a manager leaving an exhausted player on the pitch out of pure stubbornness, emotional attachment, or flawed visual assessment. It protects the club's greatest financial and sporting assets using objective biomechanical reality.
Biomechanical baselines are incredibly useful tools for recovery and training, I won't deny that. But bringing them live to the touchline and relying on them to dictate substitutions introduces a dangerous rigidity.
How is preventing an injury rigid?
I strongly challenge the reliance on these so-called critical thresholds. Let's contextualize your center back scenario. Imagine you're managing a World Cup knockout match. You are in the 85th minute, defending a fragile one-goal lead.
The pressure is at its absolute peak?
Right. Your opponent is throwing every attacker forward. The algorithm flags that your captain, your veteran center back, has crossed a fatigue index threshold because their lateral agility dropped away a fraction of a second. The tablet flashes red. Preemptive substitution required. Imminent mechanical failure.
Because the data indicates the muscle is literally about to give out.
The algorithm indicates a high probability of mechanical failure based on historical averages. But what about human willpower? What about context? A sports manager has to weigh an algorithm's fatigue index against the player's grit, their leadership, their ability to organize the defensive line through sheer verbal command.
You can't verbal command a torn hamstring.
But the psychological momentum of the match matters. If you pull your captain off the pitch in the 85th minute of a World Cup quarterfinal simply because a machine learning model detected a micro-alteration in their gait, you disrupt the defensive organization and potentially send a wave of panic for your own team.
Or by ignoring the data, you allow them to tear their hamstring in the 86th minute. That leaves a massive gap in your defense that directly results in conceding the equalizer. The problem with relying on intangible concepts like grit and willpower is that human beings are notoriously terrible at self-assessment when their bodies are pumped full of adrenaline.
They know their bodies better than a camera array does.
I fiercely disagree. A competitive player will always say they can keep going, even as their muscles are failing. A manager, swept up in the intense emotion and pressure of the match, will desperately want to believe them. The AI is utterly objective. It does not care about the romance of the moment, the noise of the crowd, or the narrative of the captain's leadership. It only cares about the reality of the biomechanics.
But by letting an algorithm prompt those preemptive substitutions, you are effectively outsourcing a deeply human leadership decision to a risk-averse machine. A machine operates on averages, but elite sport is fundamentally about outliers.
It operates on precision, not just averages.
It doesn't understand that sometimes athletes transcend their baseline data to achieve the extraordinary. Think of any iconic performance where an athlete played through exhaustion or illness. Those performances would not have survived an algorithmic threshold.
That is a survivorship bias argument. For sports management students, the lesson shouldn't be to blindly obey the tablet when it flashes red. It should be to understand that data is a servant, not a master. When you elevate the algorithm to the ultimate decision maker, you trade greatness for safety.
I find that perspective overly romanticizes the human flaw, to be honest. You are treating the AI as if it is simply making a conservative guess. It is not guessing. It is applying flawless scientific precision to variables we simply could not measure before.
Flawless is a very strong word.
But it is. And we have an ultimate proof of concept for this standard of precision right in the modern game. Semi-automated offsite technology, or SAOT.
Oh, come on. That is a highly specific, narrow application of the technology. But it utilizes the exact same technological backbone we have been discussing. When a pass is struck, SAOT uses the 500 Hz IMU sensor in the ball to establish the exact kick point. It uses the skeletal tracking cameras to automatically render a 3D topological map of the players involved.
I know how it works, but
It provides immediate, indisputable precision the moment the event occurs, ruling on the infraction in seconds. It has effectively eliminated human error from one of the most notoriously difficult and controversial aspects of the game.
for one specific rule.
The broader application here is clear. As these algorithms evolve and consume more data, sports managers will be able to apply this exact same level of indisputable scientific precision to all aspects of team management, from spatial tactics to physiological substitutions. It fundamentally removes the liability of human error from the dugout.
Holding up SAOT as the proof of concept for general management is a classic false equivalence.
How so? The tech is identical.
Yes, the underlying technology, the sensor fusion, the IMU data, the skeletal tracking, is the same. But the nature of the problem it is solving is fundamentally different. SAOT works perfectly because an offside infraction is a binary, objective rule.
It still requires immense computational precision.
I'm not denying the precision. I'm saying you are either past the second-to-last defender when the ball is played, or you are not. It is pure geometry. The line is either broken or it isn't.
And the edge computing calculates that geometry flawlessly.
It does calculate the geometry flawlessly. But tactical dynamics, defensive traps, and physiological endurance are not binary. They are infinitely complex, subjective, and interactive systems. Whether a player is offside is a fact. Whether a player is too exhausted to defend a corner kick effectively, or whether a pocket of space is a vulnerability or a trap, well, that is a judgment call heavily dependent on context.
I disagree that it's purely subjective.
The profound danger here, especially for those studying sports management, is assuming that because an AI can perfectly judge a binary offside line, its heuristic recommendations for mid-phase tactical adjustments or nuanced player substitutions are equally flawless and indisputable.
I recognize the distinction you are making between a binary rule and a subjective tactical decision. However, the entire premise of machine learning and expected threat is that given a large enough data set, what we currently call subjective tactical dynamics are actually just incredibly complex mathematical probabilities.
You're reducing human psychology to math.
Because humans previously lacked the computing power to see the math, so we just called it intuition or subjectivity. The chaotic, fluid nature of football that you champion is in many ways just an illusion caused by the human brain's inability to process millions of variables fast enough.
That is a very bleak view of the sport.
It's a scientific view. The instant mathematical order provided by the digital twin is simply the underlying reality